In this problem, we need to show that this particular expression is a constant which is independent of a and b. If it is given, then x minus a squared plus y minus b squared equals to c squared. So let's begin. So here we are given that x minus a whole squared plus y minus b whole squared. So that's equals to c squared. Now what we'll do, we'll take the derivative on both sides with respect to x. So let's take the derivative with respect to x term by term. So derivative of x minus a whole squared plus derivative with respect to x of y minus b whole squared equals to derivative with respect to x of c squared. Now here we will use the power rule. We have 2 times x minus a raised to the power of 2 minus 1. Then we have to use the chain rule and multiply it to derivative with respect to x of x minus a. Similarly, we apply the power rule first to the second term. So we have 2 times y minus b raised to the power of 2 minus 1 and use the chain rule to multiply it to derivative with respect to x of y minus b, which is equal to now c being a constant, the derivative of a constant is always 0. Fine. Next, we have 2 times x minus a multiplied to, so derivative of x minus a will be simply 1 because derivative of x with respect to x is 1 minus derivative of a, which is a constant, as 0, plus 2 times y minus b multiplied to now derivative of y with respect to x, so that's dy over dx, minus derivative of b, which is a constant, so that will be equals to 0. Now what we'll do, we'll take 2 as the common factor and divide by 2, and we'll get x minus a plus y minus b times dy over dx equals to 0. Now what we'll do, we will consider our original equation as equation number 1 and this is equation number 2. We'll be using this. Now what we'll do, we'll take the derivative on both sides of equation number 2 with respect to x. So we have derivative with respect to x of x minus a plus derivative with respect to x of y minus b times dy over dx, which will be equals to 0 since derivative of 0 will be a 0. Now derivative of x minus a, so that's going to be 1, plus here we'll have to use the product rule. So we'll have y minus b multiplied to derivative with respect to x of dy over dx plus dy over dx multiplied to derivative with respect to x of y minus b, which is equals to 0. That gives us 1 plus y minus b times, so this will give us the second derivative of y with respect to x, plus dy over dx multiplied to, so derivative of y with respect to x, so that will be dy over dx, and we have minus b, so derivative of b with respect to x will be 0 because b is a constant, so this is simply equals to 0. Now we have second derivative of y with respect to x. This is multiplied to y minus b plus derivative of y with respect to x whole squared. So this will be equals to negative 1. Now we'll take the second term to the right hand side and we have y minus b multiplied to second derivative of y with respect to x. So that's equals to negative 1 minus derivative of y with respect to x whole squared. So we have second derivative of y with respect to x. So that's equals to, we'll take negative as the common factor. So we have 1 plus derivative of y with respect to x whole squared divided by y minus b. Right. So let's label this as equation number 3. We'll come back to this equation in a moment. Now, let's come back to our equation number 2. So we obtained x minus a plus y minus b times first derivative of y with respect to 0. So you will use this equation. So from here, what we'll do, we'll isolate dy over dx. So that means we have dy over dx that will be equals to negative times x minus a divided by y minus b. Now what we'll do, we will square both sides to get dy over dx whole squared. So this will be equals to x minus a divided by y minus b whole squared. Now let's add 1 to both sides. So where 1 added to dy over dx whole squared equals to 1 plus x minus a divided by y minus b whole squared. So we'll combine the two terms on the right hand side. So on the left hand side we have 1 plus dy over dx whole squared equals to y minus b whole squared plus x minus a whole squared divided by y minus b whole squared. Now we are already provided that this value is equals to c squared. This was our equation number 1. So let's replace this. Well, we have 1 plus dy over dx whole squared. So this will be replaced with c squared. So c squared divided by y minus b squared. Now what we'll do, we'll take the square root on both sides. So we have 1 plus dy over dx whole squared whole raised to the power of 1/2. So we're taking the square root. So this is going to give us c over y minus b. Then we'll cube both sides to get 1 plus dy over dx whole squared. So we are cubing it. So this will mean simply multiplying 3 to 1/2 to give us 3 over 2. So this will be equal to c cubed divided by y minus b whole cube. So we are going to label this as equation number 4. We'll use this value. Now what we'll do, now we will go back to our equation number 3. So we'll use this equation. So what we'll do, we'll divide equation number 4 with equation number 3. So that gives us, we have 1 plus derivative of y with respect to x whole squared whole raised to the power of 3 over 2 divided by second derivative of y with respect to x. So that will be equals to, so here we have equation number 4, c cubed divided by y minus b whole cube. So this is going to be divided with number 3. So that means we have y minus b divided by 1 plus derivative of y with respect to x whole derivative of y with respect to x squared. Fine. Now 1 plus derivative of y with respect to x squared, while trying to find out the value of 4, we had an expression for this which was 1 plus derivative of y with respect to x squared. So this was c squared divided by y minus b squared. So we will use this in place of this value. So that means we have c squared multiplied to y minus b whole squared. Fine. Now what we can do, we'll see that there will be some terms that will get cancelled out. So here c and c will get cancelled out. We have y minus b times y minus b whole squared, which becomes y minus b whole cube. That gets cancelled out, and that leaves us with, so here we have a negative value. So there will be a negative value here. So this gives us finally equals to negative c. So that means, well, we have obtained our final value. So we have 1 plus first derivative of y with respect to x squared whole raised to the power of 3 over 2 divided by second derivative of y with respect to x. So we got this value to be equals to negative c, and c being a constant, so that proves the first part that this is a constant, and also we do not have any a and b part. So that means it is independent of a and